Welcome, everybody. Tonight, we're going to be working on Module 3. And in Module 3, we talk about basically flow control and local functions are kind of our major topics. We are going to be looking at some conditional operators. I've kind of gave you a preview of this already. The same with the switch statement. We got a little bit of a preview of that last week, but this week we'll go into it a little bit deeper. And then a majority of the evening will be spent talking about local functions, how to create them, how to use them, what that word even means, and why we utilize it all. So three very powerful things you'll be adding to your arsenal tonight. And it goes beyond just three things, as you will discover. The first thing that we're going to look at is what we call the ternary operator. We've learned how to do if statements, and then I very, very briefly introduced you to a switch case statement last week, if you guys recall. And, when we're making decisions in programs or we're selecting a course of action, there's a number of different ways to accomplish it. Many of the modern programming languages sort of kind of steal from each other. And you'll discover this as you're learning, like, other languages like Python or Java or JavaScript, for example, all of which utilize the ternary operators that you're seeing on the screen right now. It basically, as the slide says, it's like a small scale if else statement that you can execute with one line of code. And you can see it says commonly used to assign one of two values into a variable. That's a real common thing, or to print perhaps a really simple message that you put on the screen, right? Those are probably the two most common usages. So just take this for example. Have a variable called score. It's an integer. I'm not sure why they're using var, but it's not a good idea, but it is allowed. Then message, which there's an implied string here, I suppose. But you're checking the score to see if it's less than 60. And if it's less than 60, you fail. Otherwise, it must be more than 60, so you pass. Right. So there's two very, very simple choices. One piece of information we're actually checking, right? Very simple little statement. That could be, for example, rewritten as you see down here, right? So the ternary operator, then ultimately what it does, is we're really trying to determine what the message is. That's ultimately the goal. And so we could create the message variable and just have it wait for the result of this ternary statement. We still have to do a true false test. So this is the true false test part of it, right? Notice the parentheses because we're doing a comparison. And then we have the question mark, which implies the if. So really the if sort of comes after the true false. It's kind of weird, but this here is basically what we're testing for true false. This implies the if, and then if it's true, this is the message that will get stored. Else, this will be the message that gets stored, right? So that's kind of the weird syntax of it. But you have to admit, it is a lot more efficient than typing all that. It might not be as easy to look at, if you're used to looking at an if else statement. But you will be seeing this, like if you start like bouncing between languages, so many languages use this approach now for very simple selections. I call it common. So, and it's called the same thing in all the languages. We call it a ternary operator. And it just gives you this either or scenario, simple true false test, and one of two things that happen as a result. And both of those are typically simple test, simple results, this or that. That's a really good way to look at it. So we look at that question mark and the colon, and if you spot those in a statement and you're not sure what the statement does, and you see those two, first comes the question mark, then comes the colon, it's a ternary operator. It's easy to miss when you're looking at it. I think the colon is a really easy to miss character on the screen when your typeface is really small inside the IDE. But the previous example we saw where we were selecting a string, here we're selecting an integer. This is a really nice, simple little example right, of a scenario. If X is less than 0, then Y is going to become 10, else Y is going to become 20. Right. And you can see how practical that can be rather than writing a big long statement where you're restating Y equals whatever, or Y equals 10, Y equals 20. The statement itself does the determination. And notice like down below the statement and the quotes around it, right? If X is less than 0, assign 10 to Y, otherwise assign 20 to Y. That's not a bad way to read it because that's really what's happening here, right? Because despite the fact that we have really a simple if statement here, we are still doing an assignment, right? Ultimately, that's the grand goal here. The equal sign implies an assignment, and that means whatever happens with this on the right side of the equal sign, whatever that resolves to, will get stored on the thing on the left side of the equal sign. Right. So really, we're combining an assignment statement and an if statement. Pretty neat, and really a variable declaration all at the same time. So there's really a lot going on in that one little statement. And this is why this has become popular, because when you're doing these simple either or kind of selections, this terminology helps you write really efficient, streamlined code. And once again, workable in several different languages with practically the same exact syntax, right? We do this in Python. We do it in like the C languages. We do it in Java. We do it in JavaScript, all of those languages. And those are the key ones that you're going to learn while you're in your program, right? Probably the world's most popular. All right, let's now go to the switch statement. And we were kind of introduced to this last week, so this won't feel quite so foreign as we're talking about it because we kind of saw it in action a little bit. But we are going to go a little bit deeper dive into the explanation and how you can do some nuanced things with this and really what scenarios it's useful for. This is kind of an interesting thought because a lot of times we are kind of reliant on our user. So for example, if I ask the user how many milliliters of milk are you putting in your chocolate cookie recipe, and then you have to convert it, we're relying on the user to enter a piece of information which to us truthfully is unknown. We don't know what they're going to type in. If they're going to type in something that's valid, they're going to type in something of a certain value, or if they're going to try to break the program as they're doing it. Where a switch statement works really, really well is when you already know all the possibilities and they're finite. Okay, so I used the example last week, like if I'm creating a web page and somebody has a drop-down form where they select which state they're from, so we can figure out shipping, for example, it's a finite number of choices. There's only so many states in the union that you can pick from that list. And when I pick that list, and then it automatically looks with a switch statement to decide which shipping amount it is. Those are knowns, right? So that's I think a really nice example of that. One example they're using here is they're asking what are the possible values of an integer for month, right? Assuming we have 12 months and the numbers go from 1 to 12, it's going to be one of those, right? And in this case here, they're looking for July, August, or September for whatever reason. Otherwise, they're going to display error. But the point is, we know what the values are going in, right? We don't have to worry about the user selecting something that doesn't exist, right? In terms of how we structure the switch statement, we saw this last time. We use the keyword switch. In parentheses, we put the thing that we're evaluating. So in other words, the variable or whatever is coming in that is going to give us the thing that we're going to be comparing. There's a set of curly brackets, and inside that curly brackets are where all the additional statements will go. So for example, if we're looking for, let's say July or August with that switch example that we were looking at, the integer for July is 7 and for August it's 8. And notice how those sit inside the curly brackets. Following the statement, there is a colon indicating there's a block of code that's going to follow that's nestled underneath that case statement. And then we will be looking. But really what we're doing here, and this is really kind of weird, I want you to notice that we're not doing comparisons. We're not doing greater than or less than, or like really weird, complicated ands and ors or nots or anything like that. This is just saying, here's your value. Does this value match up with something here? If it matches up, take this action. That's the bottom line, right? And I think that's mentioned in the slide, in the slides here somewhere, right? So C# is going to look at the value in month. If there's a matching case, it will jump to it, right? So if 7 or 8 comes in, it'll go right to that thing. And then following the colon, it will complete the statement. And then each one will have a break in it. And the break allows us to exit the switch statement. If you do not include this, this will keep processing inside the switch statement. It might not hit anything, but if there's a default at the bottom, which we'll see pretty soon, it'll hit that. So that's why the break statement is important. If you don't want it to hit the default, or if you don't want it to accidentally trigger a different case, you must put that in, right? And this is a thing that you can easily forget, by the way, right? Visual Studio, though, what I do like about it is whenever you do a case, it'll kind of autofill the break. It's like, hey, are you ready for a break? You know, so and wisely so, because regular programmers often forget the break statement when they're writing these. Pretty common. So they're trying to make that point here. Right. So it does cause the program to exit the switch statement, right? So like when it hits that, pops out, doesn't check anything else. There's also this possibility of a default. So like if none of the cases hit, we can include code that will automatically execute if none of the cases, match up, right? You don't have to have that in there. Really, the logic of your scenario will dictate the necessity of having it present. Just as simple as that, right? So some situations will, imply that you need a default, and other situations will not. That's kind of up to you to basically figure out. Some people also call these case statements, by the way. I've always tried to refer to them as switch case. So I remember that there's a switch keyword and a case keyword involved. That's how my brain thinks about it. But I do see the terms used interchangeably. So some people say, oh, you can just use a switch. Or some people go, oh, you just use a case. I like to think of it as switch case. You can think of it any way you'd like. There are kind of these weird things that you can do with case statements. So for example, you can stack cases to match multiple values. So for example, I can do this sort of syntax, case 7, case 8, and then if either one of those hits, then we'll say summer break, right? Otherwise we'll say school year, right? And this is called stacking. I'm not sure if C# allows it, but I know in Java it's possible. You can also stack them in one statement. So you can do stuff like this. You can say case 7, comma 8, and that's another way to stack them. And like I said, I'm not sure if C# allows that. So I'm like kind of going from memory here that it might, well, we can always test that later if you want. But you can list them in this fashion and it does catch. All right. There are some limitations, right? So you can't do, as they're showing here, where something is less than or greater than, or ands and ors, like I mentioned before. We can only check to see if something is equivalent. And notice at the very bottom statement there, we can't do case insensitive equality. So for example, if I'm checking for somebody's grade and they type a lowercase a, that I'm looking for a capital A, that's not going to match up, right? So those are some of the limitations. So you'd have to accommodate for that, like by switching it basically before you get there. All right, let's move on to the other topic now. And you'll notice kind of the little divider here in PowerPoint. I don't know if you guys can see that on your screen where it says methods. And then we have the word functions. And so as I go into this, one of the first things that we're going to talk about is this kind of interchangeable use of these two words, what they mean, and in which context is it correct to use these words, right? In short, a function or a method, they're basically the same thing. I like to think of them as what I call a named block of code. So I'm taking some code, putting curly brackets around it, and I'm giving it a name. When I take a block of code and I name it, then I have the capability to collectively call upon it and use it to execute a series of actions repetitively, if necessary, just by invoking its name. So if I have, for example, a whole algorithm of like getting input, doing a calculation, providing an output, and then returning a value, and that's a thing that happens every time a certain action happens in the program, I can put all of that into a function, give it a name, and then instead of repeating all those lines of code, I just call the singular function and it repeats that for me, right? And so leads ultimately to reusability of code as well. Generally speaking, though, the point of this is that we call it a function when it's something that we write and put into our own program. So we call that a local function, right? Something we create. A method becomes part of a class structure, meaning it's part of a different program. So, for example, when we are utilizing some of the built-in methods or seemingly built-in methods in C#, really what we're doing is we're calling upon a different program that has that method in it. And because of the syntax we're using to call it, we're pulling it in. So when we're calling a function from a different program, it's called a method. But functionally, it's still a function. That's kind of the grand overview. All right, so I like this little blurb here where it says use to divide and conquer, right? We break a problem into smaller, manageable pieces. So you can start to think of a programming problem as like, oh, we need to do the calculations, or we need to get the input, or we need to show the menu, that kind of thing. And that might require multiple coding lines for each one of those actions, but we can think of it conceptually as one thing. And because we can block that together and call it by name, it helps us in our problem solving process because now we're thinking about it from a higher level, right? So it helps us really to solve the problems that we're trying to work on. It also makes our code a lot more readable. And so like, it's kind of like, if you go back to like the recipe scenario, it's like I can just kind of collectively say, make some chocolate chip cookies, because all the tasks involved in doing that could be considered one function, the make chocolate chip cookie function. And then on a higher level in a program can just say make chocolate chip cookies, and it just happens, right? So you see like it ultimately reads to more readable code and easier to organize code. All right, so let's look at the formalized definitions here. C# has methods and local functions. Methods exist inside of classes to be called by other programs. For example, when we do a read line or a write line, somewhere there's a program within C# called console, and that console program creates a function called readline. And so when we're using the syntax console.readline, it's really what we're doing is we're pulling up this class or program, and then we're finding this function inside of it, and it's executing, and it's doing something. We don't know what it is, right? Exactly. But it reads the stuff from the keyboard and grabs it, right? And this kind of also leads to this weird concept. So sometimes we think of methods and functions as a black box. That's kind of an analogy we hear often. So in other words, you might not know what's happening inside readline, but I do know that it captures the information from the keyboard. So I get what it does and I get how to use it, right? Or the same thing with write line. You know what write line does because that's like the first thing you learned how to do. We don't know the mechanics behind it. Kind of the same way we don't know, let's say, how to necessarily explain how an internal combustion engine works, but I can easily get in the car and go. Right? I know how to drive it. And I know that if I turn the key, it starts and I can step on the gas and go. It doesn't really matter to me how the engine is put together or what fuel it uses or any of that stuff, right? Think of it from a higher level. Local functions, it says, are methods written inside of other methods to be used only by the outer method. Okay, that's a lot of verbiage. But when we are building our programs, we've been kind of excluding what we call the top level statements. But truth be told, there is what we call a main program method. That's the one that we've been writing our code within. And that main program method is what makes our programs run. So when we're creating functions, we're going to be creating functions inside that main function that we're calling from the main function. So there's kind of like this nestling effect that's happening. I'll try to demonstrate that to you guys as best I can as we're kind of coding through these exercises and stuff. And it says here, all methods that we will be writing in this module will be local functions. That's kind of the main idea. Really, our main goal is to learn how to write a function and then utilize it, right? And to utilize it repeatedly, most likely, right? One of the biggest reasons we do this, if you create a function that performs tasks and it's useful, well, you can reuse that code. You don't have to regurgitate the code again to do the same task, especially if you're, finding yourself, oh, I already did that already. Maybe I should just create this into a function and call upon it, and it'll just happen. The other thing that's kind of cool too is if you write really cool functions, you can also pick them up, put them in a standalone program file that you can then import into your other projects and use on other projects, right? So if you write a really nifty routine for calculating sales tax or something goofy like that, there's no reason why you can't take that code with you to another program. It's kind of an interesting thought too, right? All right. All right. We also have this other issue that we wrestle with when we're working with named blocks of code, because all of a sudden we're going to be taking code, putting it inside curly brackets. And once it's inside those curly brackets, if I declare a variable inside that set of curly brackets, that variable is only available inside those curly brackets. And after the function completes its tasks, that variable is essentially destroyed, right? It does not retain its value. It comes into existence for its task, and then it's only available inside that set of curly brackets. And then once those tasks are complete, then it is destroyed memory ultimately. All right, so let's read what it says here. A local variable is declared inside a block of code. It could be declared inside of a method or local function, or even an if statement or switch case. So like if I declare a variable inside of an if statement, same scenario is true. It only exists inside those curly brackets and only while that statement is running. Okay, which is different than the other variables we've been working with. So the space inside where a variable works, we think of that as scope. So if I'm inside of a function and I've got a variable in there, I'm going to say that the variable is in scope inside that function. And then what happens if I want to access something outside the function? Then we might say it's out of scope, right? And this is kind of a thing that you wrestle with in programming, by the way, but basically the curly brackets kind of define the blocks of code and where stuff works. All right, so kind of to backtrack a little bit and talk about this main method concept just for a second. And when we are creating programs in Visual Studio, and I'm just going to go ahead and do this really quick so you can see an example of this. I'm just going to make a console program. I'm not really worried about what's going into it. I'm not even going to worry about what it's named or anything like that. But when I get to this screen, we normally leave this top box here unchecked, right? Why? Because, well, that's what I told you to do, right? Because it makes it easier to write basic programs. It's really the reality. But if you do check that box, and allow it to build out your project, you'll notice that the project will appear inside of a namespace, inside of a class called program, and then a main method where we've been coding. So all the code that we've been creating has basically been inside the main method. We're just not seeing this hierarchy. But the reality is it does exist. It is there. It's just obscured from us because we're writing something basic and we're doing all the coding in this space, basically in between these curly brackets. And we will continue to do that. But it is important to note that when you're writing a program with C# and you have this structure on your screen, the way that it works is really that the internal class or the program class is the program. The main method is the part of the program that will automatically execute when you hit that play button. If I took this code, the right line, and placed it outside the main method, it would do nothing, right? The only code that will execute is what's inside the main method. A real common way to work in C#, for example, is when you work at this level, inside the namespace and everything, you might come up with a function name, and yeah, that's a really goofy one, but it is what it is, right? Just have fun with it, right? I would create a function here, and then maybe I would put that right line statement inside of it, and then instead of right lining directly from here, I just call whatever. That's the name of the function, and then that will execute, right? Now, in order for this to operate, and this is a very rudimentary example here, but the point of it is that you call the function to run, right? And so you invoke it by name, right? It's defined here, and then whatever tasks are inside those curly brackets are part of that function. So instead of, and maybe this isn't a great example. So maybe maybe it should be called bake chalk chip cookies. Maybe that's what it's called. And then whatever steps are involved to do that, right? Your recipe steps would all be inside here, but from the main program level, I'm just calling that and it executes. But otherwise, this will not execute unless it's called from the main method. All right. This is this very simplistic example. I'm just trying to show you the basic structure of it all and how it sits, and to kind of tie that into this slide, which is kind of comes out of nowhere after we've been kind of working in the other mode. But the way that we've been working, right, so far as all our code gets in here, we don't see this other stuff. The reality is that the stuff does exist. It is there. And then when you start building more complicated programs where you have more than one program file inside the same program, then you revert back to this, because this allows you to build more complex structures, especially when you're doing GUI programming and you're creating windows and forms and screens and whatever, right? All of that becomes very, very pertinent. If you do web development in C#, like you write ASP.NET websites or something like that, this is very pertinent also. And navigating these structures is important. All right. So when we take a look at the scope, once again, of a variable, we see that there's a variable that's declared right at the top of that thing, local variable. And that variable is accessible, usable, manipulatable, if that's a hard word to say, all inside those curly brackets. Once this is done running, though, that variable disappears. It goes away. It does not persist, right? So often when we're coding in this kind of a format, if we want variables to persist, we declare them outside of the main method, like in the global space of the program, and we call those global variables instead of local variables, right? But that concept, right, is the variables only exist inside those curly brackets. If you're doing an if statement, same thing is true, right? So I have a message variable here. It works here. I can assign it. It exists in memory. The moment that it finishes doing its write line and it hits the curly bracket, it's gone. Other thing is, if the if statement never hits, it's never created. Interesting, right? How that works. But this variable here will work here, right? And then here we would get an error. So you see like the red underline here, right? Because it was not declared outside the curly brackets. I would not be able to do this or this outside that if statement. This message cannot access this one because of the curly brackets. It is from here to here, it's out of scope, is what we call it, right? One cannot access the other. So, all right. So just to kind of review this, when a program enters the if block, the variable message comes into scope. When the program exits the if block, the message leaves scope, right? So once again, can't talk to each other. Basically, you can't use a variable outside of its scope, right? You will get an error message. So for example, and this is like super primitive, but here we're trying to output the value of a variable that hasn't been declared yet. This is also a scope issue, right? So if I want to output a value, I better move this statement in front of this line because it doesn't exist yet. So that also is a scope issue as well, right? The other issue that you sometimes run into is this concept of what if you have two things named the same way? Can you do that? No, you cannot, by the way, right? So if both of these sit inside the same scope in a program, meaning inside the same curly brackets, I can't declare it once and then declare it again. It will throw an error. It won't allow it to compile. I could remove the int, right? If that was removed, then that would be fine because it's just changing the value. But I can't declare two named objects with the same name inside the same set of curly brackets. Just won't work. All right. Next thing that we'll look at is how do we actually define a local function? And this is a little weird to get used to, by the way, as soon as you start creating these, because you have to name your function. And generally the approach for naming it is to use kind of, I think of it as like action verbs describing what action it takes. Like for example, I was like playing around with baked chocolate chip cookies, right? Because that's what that function would have done if it was all spelled out. It would have all the steps for making the chocolate chip cookies. In this case, this one's called print greeting, right? Notice the set of parentheses that follow the name. Also notice how it's named, right? No spaces. We'll talk about the naming convention on it, but there's some camel casing, but instead of first capital letters in the middle, we start with a capital letter. This is kind of a naming convention for functions. Not a rule, by the way, but a convention, right? Something that commonly happens. So we also throw in this keyword void at the beginning, and we'll talk about that. And that basically means it's not returning a value. So the expression void space print greeting parentheses curly brackets and then the stuff inside will execute anytime we call upon print greeting. So anytime we call that in our code, it'll write line hello. So that's kind of the breakdown. We also tend to think of this opening part as the header, and then everything else is the body, including the curly brackets. Right. That keyword that we started with, void, once again, that means that the function does not return a value to where it was called from. If you see a function and you see a data type or a variable, format type declared before it, that means get quantity is going to return an integer back to where it was called from. So notice that, we're calling it get quantity. Looks like we're also throwing an integer into it. And then after it does whatever actions it does in the background, it will return an integer to us. If it says void, it's not returning anything. It's just completing the actions. All right. So a void method or local function performs a task, then terminates. So for example, we might write this code inside of a function. And one thing you'll notice is, hey, this is a function call. Yep. This is a function call. Yep. Right. So it might perform these tasks, and then when it's done, it just quits. It's not returning a value. So a void thing will just do its thing. The other way to look at this too is this one here is technically a method. Console is a program. Write line is a function within console. And what does this do? It puts text up on the screen. Is it returning a value to us? No. If we have a function that displays something formatted, is it returning a value to us? No, it's just doing a display. Showing a menu on a screen is just doing a display. It just does the task and then it's done. Right. If you have a method or function that's returning something, and it says here, as it terminates, it sends back a value to the code that called it. So we're using a couple of built-in functions to demonstrate. So for example, when we run the convert to int 32 and we're feeding in the price, we're expecting it to take price, assuming it's got decimal points, right, and turn it into an integer, right? So we're expecting this to return a value that then is going to get stored here. And notice what we're doing. We're setting up a variable to receive it. So we're running a function or a method inside of a different program. It's returning a value. We're storing it. Same thing with the to upper thing, right? So this we're assuming is a string of some sort. All strings have available to it all the string methods, which one of them is to convert to uppercase. So we're expecting it to take the response, convert it to uppercase, return the value as uppercase, and store it in a variable called shout. Right. So that's an important concept. So like if you are running a function and it's returning a value, you better have somewhere for that value to go. Either you're storing it or you're printing it to the screen. Typically those are the two actions that you're doing. All right. How do we name them? We try to use basically really descriptive verb names, like actions is the way I think of it. Like a function performs an action. So you should name that function in a way that reflects what the action is doing. So the one that's at the bottom of the screen there, that print menu. All right, well, okay, that sounds like it might print the menu, right? That makes sense to call it that. And this is one of those things too, where like in the old days, we'd always like be really cautious about what we name things because we didn't want to waste, memory and storage. But now the convention has become that you should be really verbose with your function names. So for example, if I have more than one menu, I might say, well, print beverage menu, print dinner menu, or print Friday fish fry beverage menu 5 to 8 p.m., that kind of goofy thing, where it's very, very specific to what it does. And the name of it really indicates what it's doing. I would also suggest that when you're naming your variables too, instead of like, x1, x2, x3, you might, say like, friend's birthday 1 or something like that. Something more descriptive is always better. They're using a format here called, it's kind of camel case, and you see how they're calling it upper camel case. And technically we call it Pascal case because it comes from that language. And that is each logical word starts with a capital letter, including the first letter. Otherwise, same rules as for variables. We can use numbers, letters, and underscores, but we can't start with a number. Those are the rules for naming them. You must have the parentheses after it, by the way. All right. I think this is a good spot to stop and take a break. We've been going for about an hour almost. So why don't we do that? Let's take a 5-minute break. And then when we come back from the break, we will resume right here, but I am going to pause the recording. Okay, we are back from break and we're going to continue on with our lecture here. Our topic, at least for the moment, is talking about methods and functions. And when we're working with methods and functions, one thing that you will notice and how you can tell that you're working with one is when something has a set of parentheses that follows it, it implies that it is a method or a function, right? Now, sometimes when we're working with methods or functions, we're putting stuff in the parentheses and sometimes we're not, right? And there's kind of couple different terms that we use basically to kind of define the stuff that goes inside the parentheses, right? And very interestingly, I was having the same exact lecture with my students last night in my Python class over at Gateway, and with my database class over at Gateway too, because we're all the topics for all three classes are functions, right? It's all hitting at the same time. It's pretty unusual, but that's how it goes sometimes. But the stuff that we put inside the parentheses are either referred to as parameters or arguments. And you hear these two words often used interchangeably. There are correct ways to use them. But I will tell you just from a practical standpoint that most programmers kind of use the words interchangeably and don't think about it. And maybe sometimes even incorrectly. So you might even watch somebody's YouTube video or something about coding and they'll say, oh, it's an argument. No, it's a parameter. No, it's an argument. It's a parameter. And there are some formally correct ways to do it. Well, I'm going to follow along with how the slideshow is put together here and go with the let's call it the C# centric approach that is demonstrated here. So let's just kind of read this. Okay, if the local function needs input to do its task, specify parameters or variables within the parentheses. So in other words, if you're putting together a function and it requires information from somewhere else, we create a list of what it needs on the inbound. And notice that as we create that list inside the parentheses, it also is kind of like a mini variable declaration. We are giving it a name and a data type. We're telling it, okay, well, we're going to send two integers in, num1 and num2. They're both integers. There are those functions that sometimes have nothing inside the parentheses, but you still need the parentheses. You cannot omit them, right? Just because it doesn't need anything doesn't mean you can omit the parentheses. They have to be there just because it is a function. If you are utilizing a function, there's this aspect of it we call calling the function, which is just to refer to it by name to trigger its tasks, right? Calling means, as it says here, execute, invoke, run, right? Make it work, whatever. And then notice here it says as a noun, a local function call or a local function invocation. And I will tell you, I never use that second terminology. I always think of it as a function call. Is how I've always referred to it, or calling the function. One really goofy thing that can happen to you when you start using functions is you can write one, you can be all confident about it and go, this is going to be great. It's going to work perfect. It's going to solve the problem. And then you run your program and nothing happens. And the failure is you forgot to call it to run. It's kind of like getting in the car, sitting at the wheel and going, hey, I'm not going anywhere. And it's like, well, you never turned the key. You never started the car. You never asked it to go, basically. And functions are the same way. If you don't ask it to run, it's not going to run. And that's what we call the call, right? here's kind of a simple little example. So the top part of the screen here is just a program, right? We're doing a write line, and now we have this thing called display message, and then we do another write line. Display message, when it's called, we'll search through the program, find the function called display message, right? Notice this is a void one. It's not returning anything, but it does write to the screen. Kind of interesting. So this is the call to make the function trigger this code. All right. Now, if you think about like if you have a program that puts like a menu of choices on the screen, that's a real good thing to put in a function, especially if that menu has to come up all the time, right? You just say display menu, and it'll put it up there. But this would be an example of a call to a function. Without this piece of code here, this would never trigger this function down here. It is also possible, and this is kind of a weird approach to explain it, but sometimes people say, well, can I call a function from another function? Yes, you can. And then can I use that function to call another function? Yes, you can. And then can I use that function to call a different function? Yes, you can. Right. So this is kind of goofy example, but by triggering this code, right? So I'm calling level one, the function. Level one triggers level two. I go to level two and it triggers level three. And then level three will just say console write line hello up there, right? That's totally allowable and not really all that weird. This is a weird example, but the point is that one function can call another as long as it's in scope and can reach it, right? So I think this is really kind of fascinating. And so sometimes you'll take other functions and run them from a different function if it's logically sound to do so, right? An interesting thought, right? So here comes that word arguments, right? And I always think, like, whenever I hear that word, I always think of like the Monty Python, this isn't an argument. Yes, it is. No, it's not. Yes, it is. But argument is kind of this keyword that we use. And notice what it says here. Arguments are the values that are sent into a local function or method. And this is correct. So for example, when I call write line and I throw this string inside the parentheses, hello literally is an argument. It is the information I'm passing into the parameters of the write line function. So from the perspective of the function, the incoming information is a parameter. From the perspective of the rest of the program, the stuff we're sending to the function is called an argument. That's the correct syntax. Okay, so I'll go back to that thing I said before. Even experienced programmers will often confuse the two terms, right? And use them interchangeably. So if you hear parameter or argument, the real simple way to look at it is it's the stuff inside the parentheses. When it's technically correct, if you're sending it, it's an argument. If you're receiving it, it's a parameter. That's kind of the, the correct nomenclature. All right. A local function to display currency. So here's an example where we have this parameter, right? So from the standpoint of the function, this is a parameter. It's a double. It's going to accept a monetary amount. And then inside the parentheses, right, this becomes a viable variable. So we can use it inside here, right? So that parameter list is utilizable inside the program code. Now, from outside the program, I'm going to send a value in here. What does this function do? It's going to take an amount, it's a double, and format it as currency, right? It's going to put, the C2 thing formats it as currency with 2 decimal places. If I was to utilize this from outside the program, I can utilize it in a number of different ways. For example, I can call the function and I can either hard code a value in, like one number, I can put in a whole calculation, or I can put in a variable that has something in it. Here they're using the example of a calculation. That's totally allowable, right? I think this would be slightly unusual to do it like this with hard-coded numbers. It'd probably be variables really. But as long as, what it's sending in is a double, then this can accept it and process it, right? So this argument gets passed into this parameter and is processed by the function. Right? There's the weird terminology. All right. So if you were to use that function a few different times, I might do something like this. I might take a number that's resolves to a double, store it in a double variable, take that double variable, send it to the function, right? And then take that subtotal and multiply it by a different number and send it to the function, or just have it display this. But all of these would basically end up displaying a monetary amount, right? And all of them would accomplish that. I think this is kind of an interesting little example because it shows like all the different formats that you can throw in variables. You can throw in a variable multiplied with a number. You can just throw in a number. You can take some numbers and put them in a variable and then send that variable over. All of that works, right? It's not really picky about how it receives it. And once again, always driven by the logic of what problem you're solving, by the way. Now, there is kind of a little bit of an issue with the compatibility of data types here. So this becomes a thing that we have to think about. So that display currency function is designed to receive a double. Here's an example at the bottom of the screen where we're trying to send in an integer. Will that work? All right, so the last little statement there says, C# will automatically do what we call a widening conversion. We talked about this like super briefly before. And what that means is if I'm sending an integer into something that's a double, okay, that'll work because really it's 7.0, right? So I don't have to worry about like hidden like values or anything. So I can take that whole number and convert it to a double, no problem. That'll work. And C# allows for it. So I can take a number with no decimal places and feed it into that where it's expecting a double and it will go, right? To go the other way though, if I have a double and I want to throw it into a thing that is expecting an integer, that will not work. I do have to do a cast to it. So I have to like, before I send it in, have to understand that that's the case and convert it to an integer before I send it in. Otherwise it will fail, right? And if you think about it, it makes sense. Well, in this case, that number isn't a big deal because there's no value after the decimal point, or at least as far as we know. It might be rounded, right? It could be 5.01 and it rounded to 0.0, but it's really, there's a 0.1 there, right? But if we are narrowing it down, it is going to convert. So you have to also understand what the conversion does to the number as well. Right. So that is a consideration. Normally, we want to send the stuff in the format that it needs to be. Right. All right. So parameter variable names. So this is kind of weird because now we're talking about how we name stuff inside the parentheses, basically. And it says it's not required for an argument variable to have the same name as the parameter amount. So for example, the function is expecting to receive this value, which is an integer, and then that name, of course, is used inside the function, right? So this is basically a local variable for the function. When I'm sending it in externally, this doesn't have to have the amount variable name here. It can be whatever, as long as it's a valid data type for what's being sent in. So in other words, if you run into the scenario where this was actually named num instead of amount, it is a different num than this one. That's kind of the point, right? So the reason I bring that up is like if you guys have done Python coding before, and this is a mind bender because I like right now I'm teaching an intro Python class, and I have people that are brand new to coding, never heard this stuff before, and then I have people who have coded before, taking the Python classes and elective. And when I showed them in Python, it's like, oh, it doesn't matter what you name it. And they're like, what do you mean it doesn't matter? I was taught in Java that I have to, or in C sharp, I was taught that I have to make sure all the names are different. So the truth is, even in those languages, I could name this num, I could name this num, the same name, but they are two different nums. They just happen to have the same name. They exist in a different scope, is really kind of the reality of it. The better practice, of course, is to have different names. But we see this almost as kind of like a intentional approach in the Python language where people will name stuff the same. And I'm like, why would you do that? And it's like, well, you can do it, so just do it. And then you get to a formal language like this, and people are like, no, 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 don't name them the same if you can help it. The truth is, you can. It's just not a smart idea. It's the point
Is
trying to
that
be.
is that because of the first one being a argument, like show quantity being an argument, then is bringing back a parameter?
No, Anthony, it's really more about where the variable is valid, right?
Okay.
So this variable up here, num, works
Hmm.
inside the space because it's outside those curly brackets. If I went
Okay.
ahead and named this num,
Hmm.
like, and both of these were named num, this would still work. And whatever value this is right here will
Sure.
not interfere with that, but they are coincidentally named the same thing, but those
Mhm.
variables don't talk to each other. They're really different,
Okay.
right? And if you want to, like, maybe you could think about it like, hey, there's a guy in your house named John, and there's a guy named John in the house next door. They both have the same name, but they're not the same John, right? They might even have the same last name. That might even be a better example.
Actually helped a lot.
All right. All right. So the let's talk about the scope again, right? So this is kind of um this is continuing the same thought, actually, right? So we're making the same point again. And basically a parameter is a local variable. So in other words, amount is only functional inside these curly brackets. It's declared here, but it's basically a variable for this. It's just expecting to receive that, right? So we say it's scoped to the local function, right? We can only refer to it by name inside the body of the function. So if I wrote code outside the function that tried to access amount, it wouldn't work, right? Because it's not, in the same space, basically. You can also, by the way, pass in multiple values at the same time. It doesn't have to be one value at a time, right? And some functions are built for that. So here's an example of a function that receives two integers. Notice the comma, right? And then each one is declared with its data type and its name. So really, we're sending in num1 and num2. Then inside the function, those will be utilized. So they'll be added together and it'll display on the screen, right? Um, but we keep those separated with commas. Each one is declared as a data type. What you cannot do is you can't do abbreviations like this. So I can't say int num1, comma num2, implying that they're both ints. That doesn't work. Each one has to be separately declared like this, right? So don't do that. That doesn't work. All right. So if you are passing in multiple arguments, what does that kind of look like? So here's an example of a couple ints, A and B, 5 and 6. So if I have that show some function, right, I'm sending in my A and B, right, and it does the work. I can also send in equations with those variables, right? So I can add them together, multiply them together, and then the result of the addition and the multiplication then go into the function and do their thing. Um, I'll be real frank. I very, very, very rarely do math inside of a call to a function. I think that's a little odd, frankly. You know, People do it, but I think it's a little odd. You can also hard code values, so you can still use literals in the statement. Like, maybe something like this you might see. It's like, hey, whatever A is, double it before you send it in. Okay, fine. We don't need to store that value, so we can do it in the call. And because these are also valid integers, negative number works. So I can hard code stuff in there. The important thing that I will also point out here is that whatever order you're sending the numbers in right, so double ins there, that's the order that the function is expecting to receive them. So if your first parameter is an integer and your second one's a double, you better send them in that order: integer first, then a double. And that we haven't talked about that topic yet, but that is an important topic as well. So once again, back to the argument versus parameter thing. It says terminology differs among languages and disciplines. The parameter is the variable, the argument is the value. The value we're sending in is the argument. When it's received, it's a variable to the function, right? And arguments are passed to parameters. App is a little acronym if you want to remember that. I don't think that, like I said, this is such a key issue, because I hear professionals who've done this for decades interchange those terms and say them incorrectly, and nobody cares, by the way, right? In the professional world, you say arguments or parameters, and people are like, yeah, whatever. Right. It's the stuff in the parentheses. Got it. Okay. All right. So let's talk about this weird concept, which is a local variable lifetime. So local variables only exist while in scope. This is really pretty bizarre, right? So, and this is by design, by the way, right? So like in modern programming languages, we create a variable inside of a block of code. It exists long enough to do its task. So whenever we set up a variable, keep in mind, we're reserving a memory location, we're giving it a name, and we're giving it a data type, which also declares the size of the memory location, right? So like if I say int 32, it's different than a tiny int or whatever, right? All of those like weird little data types. As soon as the code executes and we're done with that block of code inside the curly brackets, it's destroyed in memory. It is erased. Okay. Why does that happen? Well, the reason why that happens is this is called automatic garbage collection, is technically what they call it. One of the first languages that had this as a feature was Java, right back in the early 90s when they introduced this. Prior to that, often what programmers would do, especially if they were coding in, like, for example, the C programming language, they would allocate a variable and then they would have to write code to destroy it, to free up the memory to make it available for something else. You'd have to think about that, right? And like, wow, what a pain, right? You would have like, hey, I created this variable, I stored some numbers, I did some math, now I have to destroy it. It's like taking the garbage out. And I mean, that's really a good name for it, right? So like when Java came out with this concept of automatic garbage collection, which is clearing the unused variables from memory automatically, it really simplified programming quite a bit. And all modern languages do this now, by the way. All right. And then it says at the bottom here, when a local function is done running, the memory holding its variables is reclaimed, right? So in other words, we have that memory available to other parts of our system now. And think about how important that is when you're working on a system and you're running really complicated software and you're trying to run another piece of software and watch Netflix and play a video game and chat with your friends. It's all this like stuff. Everything's competing for memory and resources. If our programs didn't automatically release the resources, we would have some problems, right? And so this is an important feature of modern programming, I think. All right. So the concept here is value returning local functions. It says data goes into local functions through parameters and arguments. What if the data needs to come out, right? And like I mentioned this before, sometimes you do need your function to return a value, like to do a calculation, and what's the result of the calculation, for example. So if all the local variables inside of it are getting destroyed, how do we do that? Right. And so they developed basically this mechanism called the return statement. So we use the keyword return So for example, if I send in two integers to this function called sum, and it totals them, stores them in result, right, which is a local variable that will get destroyed, I can still return the value of result. And then notice in the function definition that the keyword at the beginning of it is int, implying that we are returning an integer when we're done. So basically, what this becomes, instead of using the keyword void, which returns no value, it just does the task, int is saying we have a pipeline to return a value. Result, the variable result will still get destroyed, and num1 and num2 will also get destroyed, but the result will be pushed back to where it came from. The real tricky part of doing that, right, is it needs somewhere to go when it's coming back, right? So there's the return statement. And so, for example, right, if I'm calling that sum function, right, and I'm sending 5 apples and 7 oranges to, total up to 12, I know that this is returning something, so I need somewhere for it to go. This is a really good way to do it, right? You set up an integer variable because we know it's going to return an int. How do we know that? Because it says so, right? What's it going to return? An int. Okay. All right. So it's returning an int. And then where do we put that int? Right? In a variable that's an int. So this is returning a value. We need somewhere for it to go. Whatever's on the right side of the equation, whatever that evaluates to, gets stored on the left side. Another approach, right, and they're not really showing it here, is that the sum function call could go directly into a console write line. Also, you could do that, right? And I'm not saying that's the best way to do it, but that is doable for sure. All right. So what if you have multiple return statements? Is this allowed? Right? Is really kind of a good question. Now the reality is only one return statement can operate in a function. However, it doesn't mean that you couldn't have multiple possible return statements. So like an if statement, for example, is a really good example. So if I was like, get tax rate, and we had a big complicated if, else if, and had every state in the union listed here, or maybe even a switch case statement, right? And each one of those would return a value, right? Whenever it hits a return statement, what happens is code's done running, it's out. So if the state was Wisconsin, it hits the return statement and we're done. If the state's Minnesota, hits the return statement, we're done. If neither one hits, then we just return 0. Right? But either way, it's going to return something. So if you're ever asked, can you have multiple return statements? Well, technically, you can't have multiple ones that actually all operate. You can have one out of many that operates. Usually you have some sort of if or switch case statement doing that operation, right? All right, so it says here, the return statement doesn't have to be the last line of the local function. Executing the return statement will exit the function. I think we said that, and all possible paths through the function must result in returning the correct data type. So if you're telling, the world that, hey, you're returning a double, you better be returning a double, right? So you have to make sure that happens, right? One way or the other. All right, folks. So we've reached the end of the lecture stuff, which is like, woohoo, right? We still have time left tonight because the main goal on a Tuesday night is to get through the lecture materials. And we do have a try it exercise here. And I thought what might be kind of cool to do is that we work on this and try to get this to work. And I'll record this all into the video too, so that we have it as kind of like a practice piece to look at. And then once that's all done, then we can take a look at like the Codio exercises or any other questions that you guys might have. Right, we should have plenty of time to accomplish all of that here tonight. All right, let's take a look at the task here. And it says, you have been tasked with creating a clairvoyance tester program. It should have a local function that generates and returns a number between 1 and 10 using this code. So like what you're seeing here is the methodology for generating random numbers, by the way. And we'll try this code. This is pretty cool. After that function is called, ask the user for a number between 1 and 10. Create another local function that takes the random number and the user guess number as input. If they guess correctly, return the string, you are clairvoyant. If not, return, sorry, you do not have clairvoyance. Now, what I'm going to do here is I want to keep these instructions handy. So I'm actually just going to kind of pull them over to the other screen here so I can keep looking at them, because I will refer to them, right? I want to make sure I'm doing all the tasks that are described. And I'm going to bring up Visual Studio here, and I'm going to go ahead and try to code this. And you guys should do the same. You should follow along with me as we're doing this. Right, so I'm going to go ahead and create a new project. It will be a console app. I'm going to put it where I normally have been putting it for this semester. This is the folder where we want it. And then I'm going to name it Clairvoyance Tester. Right, that's what it is. And actually, and say mod 3 try it, just to help me remember where it comes from. I'm going to uncheck that do not use top level statements box. So we just want to be right inside the main method, and we're going to click create. All right, so there we go. I'm going to clear out the code that I have here. And then I'm going to try to build the program as described. Now, goofy stuff, you know, real frankly, that programmers kind of do. They do like weird little things like this sometimes. Like sometimes they will label their apps, you know, and they'll get all fancy and make little like ASCII art boxes and stuff. I don't know if you guys like doing stuff like that, but you can, you guys are like, what the heck is he doing? Yes, I'm making ASCII art here, folks. All right, whatever. If you want to label your stuff and make it look cool, you can do that. The other thing to kind of keep in mind here is we're technically still inside the main program, right? For this, and I'm going to be creating functions inside the main program that are all going to execute within the main program. So basically, the general operation here is going to be for me to create the functions, put them sort of at the bottom of my screen, and then call them from the top of the screen in the order I want them to operate, right? And so up here will be the, and I'll say it like this, steer the program. I'm going to pause here for. All right, so let's get back on the track here. And you know what, you guys have to excuse me because you know I'm switching languages all the time. How do you actually do a comment in C#? Because I'm noticing this is all underlining. I'm like, yeah, you can tell I was in Python land yesterday, right? Yeah, we want to use slashes is what we want, or CSS style is another approach, right? Yeah, I don't want to get too persnickety with that stuff. All right. All right. I might even call that like a control panel. So in other words, I'm going to write some functions, and then we're going to have those functions called from the top of the program. So I'm just leaving a spot up there to do that. All right. So now we're going to write the functions, and we should have a local function that generates and returns a number between 1 and 10 using this code. So here's the code that they're giving us. So I'm just going to copy and paste this in. I'm just going to drop it in right there. But I want to begin by creating a function, and I did hear it say return a number, right? So what are we going to return? A counting number, which is going to be an integer. And what should we call this? What is this thing going to do? I don't know. It's going to generate a number for us, right? Okay. So why don't we call it? I'm just
Number.
being bold here. Generate number. How about that? That works, right? Um, we weren't told that it needs to receive any values. So I'm not giving it, you'll notice here, um, any parameters inside the parentheses. Because think about this. If this is capable of generating a random number and returning it, I really don't need to send it anything. That's all it does. Performs a task and returns a number. All right, so let's take this statement then and paste it in. You can grab that from the PowerPoint, by the way, or from the chat. You guys don't want to type it, so you can just grab it from there. But while we're on this topic, and I'm gonna talk about this just for at least a moment, there is a random number generator that's built in to just about every programming language. You just have to know how to call it. So this in C#, the way that we do it is we call the random, and you can tell, you guys noticing some of this stuff here, that this is a function, right? And then that function within it has another method called next, right? And what this one does is it basically sets the parameters for the starting and the ending values it can generate. Now, this is kind of a weird tool, because in order to generate a number from 1 to 10, I have to make the last value 11, right? And this is just how the thing operates. So don't but it is 10 possible values that it will generate, right? It's going to generate that number that will actually become an object, right? And we haven't learned about objects in classes yet, but that's what this implies. And that will get stored here. That number will get stored. So ultimately, after it's generated, we just want to return that random number, right? That random number will be an integer. We are telling it that we're sending back an integer. Now, you notice how this was underlined before? Like before I had the return statement, what it was really screaming about is that, you're saying that you're returning something, but you're not, is what the error message is. And that's the top one, right? It says, not all code paths return a value. Well, once I add that in, then it changes. Now it's got a green line. And what's the problem with the green line? We have a function that is declared but never used. So if you create a function and it underlines green, you're like, what's going on? Well, in order for this to work, I have to call it. So I'm just as a starting point, I'm going to go ahead and use that function. See if I can even type it. Okay. So now I'm calling it. Well, this is kind of weird. Well, it's going to return a number. That number needs somewhere to go. So you guys feel where I'm going with this? So even though I can call it and it's returning a number, it's not going anywhere right now. So I would also probably have to create an int, and maybe I'll just call it, I don't know, num1. Or really, this is how about we call it magic number, right? This is the one that automatically is generated by the computer. How about that? That's the magic number. And then I can see if my random number generator is working by just printing out. And yeah, let's see. Look, you can tell I'm in Python mode in my brain.
Yeah, I was like, console right
I was coding all Python yesterday, and today I'm coding C#. I'm glad you're getting a kick out of it, Anthony, because it happens to my brain a lot when I'm switching between languages here. And yeah, I don't need double quotes here. I can just output the magic number directly. What I really want is And you know what? It's saying convert to string. Fine, I'll convert it to a string. Um, I just want to prove that it's working, that I'm calling the function and it's working. Okay, so let's just run it. I just want to make sure that this is running. Here comes the run. All right, well, check it out. It generated a 4. How do I know it's really random? I don't know. Run it again.
Yes.
Yeah. Right now, we haven't learned looping yet, but this time I ran it and it's a 5. Right. So the point is I want to make sure that it's actually doing it. Right. And ideally I would test that a whole number of times. All right. So there's my generate number function. That's working. Right. So I have proof that that works. That's good. Right. All right. Whether or not I'm going to use this code to steer the program, probably not. But you know what? I might do a couple of other really goofy things. And I'm doing this mostly for the sake of demonstration. And so I'm just going to put a little thing here. I'm going to say define the local functions as an example. So I got generate number. That's working just fine. It's been tested. But what if I created one that's just a void function that is like, how about display welcome message? And then we want our curlies here. And then how about with that one, I just do a console write line and say, maybe I could use my fancy ASCII art here, actually, now that I'm thinking about it, but no, I won't do that. I'm just going to say clairvoyance tester. How about something goofy like that? And then maybe I put like a blank, we maybe do a blank line after it and a blank line before it, something like that. You want to get all fancy with it, do it. But kind of the point here is, right, whatever this welcome message is and whatever stuff I do with it to like kind of make the program look cool or better. Like for example, like maybe I could count out the number of characters here. I don't know how many that is, like I don't know, bunch, right? And then maybe I could do my ASCII art. Maybe I could like, maybe I totally get into it and create some ASCII art here, and then maybe even close out with some ASCII art. You notice I'm putting it all on like one line, and then do another blank line, and then here where I'm going to steer the program, I can just simply say display welcome message. And then did you notice that the IntelliSense actually found my function this time? Right. And eventually, as it learns your functions, it will help you auto complete your own functions. This is kind of a neat thing. So in other words, I'm going to run the program. I'm going to start the program. It's going to display the welcome message, then do a random number and show it on the screen. All right, so let's try it. Let's see if it works out. All right, my ASCII art is horrible, but whatever. I don't care. It looks like I need a bunch more hash marks on the top line, like 1, 2, I don't know, whatever that is, 8 more, and then 10 more for the other one. All right, but it did work. So let's go 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, guessing. Right. All right, so that's my silly little thing, but it's kind of a demonstration, right? If I wanted to, for example, display the welcome message several times, and I know this is kind of pointless, but I could do that, and notice how much easier that is than trying to figure out the hash marks each time, right? And all I did was call it. So this is kind of the power of functions, is that capability to do that over and over again, right? All right. Okay, so let's move on with the next direction. So I should have a local function that generates and returns a number between 1 and 10. We did that. After the function is called, ask the user for a number between 1 and 10. So, right. So we're not going to display. So we're going to call that function and generate the magic number. Now we're going to prompt the user, right? Why? Because it told us to, right? So we're going to say console write, right? Because we want the prompt to stay on the same line. And we're going to say, enter a number between 1 and 10. Maybe do something like that. And now we want to read that in, right? We want to store that somewhere. A string variable makes sense, right? And no, not string. We want to make that an int, right? Because we're going to compare numbers. And so how about we call it user guess, right? The user is guessing the number. And notice how it's recommending I generate a random one. No. We want to do a console. Now I'm going to do a read key. We're going to do a read line. And do we want to do a convert on this?
Probably not.
What was that? Anthony, your voice is kind of breaking up there a little.
Looking at my code, what I have, I'm just trying to see.
Got a squiggly line under it, so I'm guessing maybe.
Maybe.
Well, I mean, it's got a squiggly line, right? Because it knows I'm going to pull in the string, but I do need the convert to, right? I still need the read line, but I am going to wrap parentheses around it, right? And then in front of it, I'm going to say convert to int 32, right? Is kind of the standard. So now it'll take whatever they type, right? Convert it to an int, store it here. Now, are you guys recognizing something else though? We already learned that console like write and like this is a program, this is a function or a method within it. This is a program, this is a function or a method within it. You see, it starts to help you kind of unlock stuff, right? All right, so we have computer generated a number, the user generated a number. Now the task is as follows here. So here's the next task. Create another local function that takes the random number and the user number as input. So those are going to be our arguments or parameters, right? And then we'll feed that in and then we're going to ask some if questions. So what is, right? And we wanted to just display a message, right? No, actually I'm reading it a little more deeply. It says, if they guess correctly, return a string. So we're going to return a string this time, and then we'll have to display the string. Okay, so I'm going to kind of do this in a weird sort of fashion here. So I know that I need to create a function that returns a string, and let how are we going to name this? And we are going to receive what? 2 integers, right? So the first integer would be, well, notice what I named it here. I named it magic number. I don't want to name it the same thing here, right? And so what should I call it?
User number.
Magic? How about magic? Right. And the other one's going to be an integer too, but we'll just call it guess. Right. See how I'm like trying to use different names so that they're separated. All right. We are going to end up returning something, right? And that's why it's underlining red. We know that. But now we have to do an if statement. So we have to figure out if And I love how like Visual Studio just like tries to audio type this here for me. Oh, if magic equals 0, yeah, well, good guess, but that's not what we're trying to figure out here. What we're really trying to figure out, I'm just going to accept it, but I'm going to tweak it. So I'm going to say if the magic number coming in matches the guess, that's really what we're testing, right? So if they guessed correctly, we will return a string, right? And notice I'm just going right to the string, right? Not storing it or anything like that. I'm just going to return it. I'm just going to say, you are clairvoyant. And then a semicolon, right? Else, isn't that interesting how it split the else? And I don't know why it does that, right? Else, return, and I'm just looking at the pre-generated message. Sorry, you do not have clairvoyance. That is a weird word to type, by the way. Another thing you might want to do, and I'm, that's all we're asked to really do here, by the way. But I think that that's kind of lame. Okay, so like, don't you want to know what the random number was? I would like to know. Right. So I'm just telling you. So I'm going to do a thing here. And we can do this obviously a few different ways here. I'm going to do the string interpolation approach here. Right. So I'm putting the $sign in front, and I'm going to say the magic number was, and then we'll use the curlies here and just say magic. And you guessed guess. All right, and we'll close our parens and a semicolon. So in other words, I'm going to show them just really quickly, what happened, right? Just so they know. And maybe I should be smart here and put a blank line in front of it. The magic number was, and you guessed whatever. And then it will return, you are clairvoyant. Sorry, you do not have clairvoyance. I forgot my semicolon here. Thank you, Visual Studio, for letting me know. And then I'm going to need to receive this somewhere. So in other words, this is going to return a string. And now I need to put that up on the screen. Okay, so how do I ultimately call the function to run? Okay, so I'm going to create a string variable. I'm going to put a question mark on it. And then I'm going to say, how about output? Well, let's just call it message. I think it's probably good enough. And then it's going to be the result of running the clairvoyant function. So notice how it's finding them now, right? And then what am I sending into it? The magic number. And are you guys noticing how it's picking up what it needs? It's telling me what it needs, and then it's also showing me the variables that probably make sense to send. So magic number, and notice very intelligently, user guess, well, it's the only other integer there is, so I guess it makes sense. And then we are just going to simply do a console write line with the message. And you know what? I'm going to put a new line character in the message here, just to give it a little bit of spacing. All right. So we're going to steer the program from here. Right. So display the welcome message, generate the magic number, prompt the user to enter their guess and capture it, and then take that guess and the generated number, send it to the clairvoyant function. It'll come back as a string, which we'll store here, and then we'll output that to the screen. Right. So we have called our one function, the other function, and the other functions. We created 3 functions, and we're calling 3 of them, and we're using a bunch of other ones, by the way. So here comes the program run. Let's hit the run button on this. All right. Clairvoyance tester program. Enter a number between 1 and 10. All right, I will type in 5, right? That's the number you should probably guess. And the magic number was 3. You guessed 5. Sorry, you do not have clairvoyance. And it is correct. All right, so very simple little run. I'm going to run it again. Right, I'll guess 1. I'm going to keep guessing until I have clairvoyance, by the way. Hey, there you go. I am clairvoyant. It just takes, it's a 10% chance of being clairvoyant, basically. If you actually were nailing it every time, I would get a little afraid. All right. So this is an example then of doing the try it exercise. Did everybody get it to work?
Mine's not working.
All right. I'm going to stop the recording here, and then we'll take a really quick look